Look around the room you're in. The walls, the floor, your own hands. Every atom of it adds up to about 5% of the universe. 5. The stars you've ever seen, every planet, every comet, every living thing, 5%. The rest is dark. Most of it, around 85% of all the matter that exists, is something we cannot see, cannot touch, cannot catch, and cannot name. We just know it's there, because without it, galaxies would fly apart like a carousel spinning too fast. We call it dark matter, and that name is mostly a confession. It means we know there's a ghost in the house. We've measured its weight. We've mapped where it stands. And we still have no idea what it is. These are 10 places where that ghost stops behaving. 10 anomalies that should have been solved by now and weren't. One of them is a storm blowing through your body as you sit here and you can't feel a thing. Number 1, the bullet cluster. Picture 2 galaxy clusters, not 2 galaxies, 2 clusters, each one a swarm of 1,000 galaxies, running straight into each other at a few thousand kilometers a second. This actually happened about 3.5 billion light years away, and we caught the aftermath frozen in the sky. Here's where it gets strange. When the 2 clusters collided, the hot gas between their stars slammed together and slowed down, the way 2 crowds shoving through the same doorway jam up in the middle. That gas glows in X-rays, and it's piled up right where you'd expect, stuck in the center of the wreck. That's the normal matter. That's the stuff made of atoms. But the gravity didn't stop. You can map gravity by watching how it bends the light of galaxies far behind the crash, like looking through the bottom of a wine glass. And when astronomers drew that map, the gravity wasn't in the middle with the gas. It had kept going. 2 huge invisible lumps of mass had passed straight through the collision and come out the other side, sitting out ahead of the glowing gas, untouched. Think about what that means. The mass and the matter are in different places. The thing with the gravity sailed through the crash like it wasn't even there, because as far as it was concerned, there was nothing there to hit. That's dark matter, caught in the act, peeled away from everything you can see. For a lot of physicists, this is the closest thing we have to a smoking gun. You can practically point at the empty space and say, that's where it is, and nothing's there. So why is it on a list of things we can't explain? Because of how fast it was going. When you run the numbers, those 2 clusters were closing in on each other at something like 4,500 kilometers a second. That's around 10 million miles an hour. And when scientists asked their best model of the universe how often a crash that violent should happen, the answer came back. Almost never. A few times in a billion. The bullet cluster is supposed to be the trophy that proves dark matter exists. And the same trophy is moving so fast it shouldn't exist at all. Some researchers have spent years trying to talk that number down, finding ways the collision might have been a little slower, a little more ordinary. Others keep finding it sitting right on the edge of impossible. So we open on the best evidence we've got, and it's already arguing with itself, and that's the gentle one. Number 2, the galaxies with no dark matter. Every galaxy we've ever weighed has the same problem. It spins too fast. The stars on the edge are moving so quickly the galaxy should be flinging them off into the dark, and it isn't, because there's a vast invisible halo of dark matter holding it together. That's the rule. Big galaxy, small galaxy, it doesn't matter. There's always more dark matter than stars, usually 5 or 6 times more. No exceptions. Then, in 2018, a team led by an astronomer named Peter Van Dokkum pointed a telescope at a faint smudge about 65 million light years away, and the rule broke. The galaxy is called NGC 1052 DF2, and it is barely there. It's so thin, so transparent, that you can look right through it and see other galaxies on the far side, like a jellyfish in dark water. They watched the clusters of stars inside it drift around, and they drifted slowly, lazily, way too slow. They did the math on how much mass it would take to make them move like that, and the answer was just the stars. That's it. There was almost no dark matter at all. A galaxy made of nothing but the stuff you can see. Now here's the part that breaks your brain a little. A galaxy that's missing dark matter is actually some of the best proof that dark matter is real. Think about it. If what you were really seeing was just gravity behaving weirdly, If there was no separate dark stuff, only a new rule of physics, then every galaxy should follow that rule. You can't have a galaxy that opted out. But if dark matter is a real separate thing, a substance, then you can imagine situations where a galaxy got separated from its share of it, where something ripped it away, and people thought maybe it was a fluke, a measurement error, until the same team found a second one, NGC 1052 DF4. Same ghostly look, same missing mass, sitting right near the first. Then, just this year, a third turned up along the same trail in the sky. The leading idea now is that they were all in a hit and run, a high-speed collision between dwarf galaxies that knock the dark matter clean out of them and let it drift off on its own, leaving the stars behind like a car with the engine torn out. So in 2 items, we've gone from dark matter that won't slow down to dark matter you can apparently steal. We still can't tell you what it's made of. But we're getting very specific about how to lose it. Number 3, 40 years of detectors that found nothing. For about 40 years now, we've been trying to do something that sounds simple. Catch one. Just one particle of dark matter in the act of bumping into something we can measure. Because if it's a particle, and for decades the favorite guess was a heavy, shy little thing called a WIMP, then once in a great while one of them should drift through the Earth and clip the nucleus of an atom, and we should be able to see the tiny flash. So we built traps. The best one right now is called Lux Zeppelin, and it lives a mile underground in an old gold mine in South Dakota, because down there, the rock blocks out all the noise from space, and you can finally listen for something that quiet. Inside it sits 7 tons of liquid xenon, chilled and watched by hundreds of sensors, waiting for a single spark. In December of 2025, they reported their latest results. They've been watching for over 400 days. The most sensitive search anyone has ever run, the largest haul of data ever collected hunting this thing. Nothing. Not one confirmed flash. The WIMP didn't show. And this is the pattern that should bother you. Every few years we build a detector 10 times better than the last one, dig it deeper, make it quieter, and point it at the dark. And every few years it finds the same thing the last one did, which is nothing. We have now searched so well, ruled out so much, that the detectors have started picking up a different ghost entirely. Neutrinos from the heart of the sun, drizzling through the planet. That's a floor. Physicists call it the neutrino fog. And once you're in it, finding dark matter gets harder than ever, because now there's a real signal in the way of the one you actually want. So here's where we are. We can weigh dark matter across a whole galaxy. We can map it after a cluster collision. We can point at the sky and say, there, that's its gravity. And after 40 years and a mile of rock and 7 tons of xenon, we have never once held a single piece of it. We know the ghost is in the house. We just can't get it to touch anything. Number 4, the one experiment that won't stop seeing it. Except there's one detector that says it found dark matter a long time ago, and it will not take it back. Deep under a mountain in Italy sits an experiment called DAMA, built around crystals of sodium iodide. And for more than 20 years, DAMA has been seeing something the others don't. Its signal goes up and down across the year like a slow tide. It peaks around the start of June. It bottoms out around the start of December, every single year, like clockwork. And that is precisely what dark matter is supposed to do. The whole solar system is plowing through the galaxy's dark matter, so there's a kind of wind of the stuff blowing past us all the time. But the Earth also goes around the sun, so for half the year we're flying into that wind, and for the other half, we're riding along with it. The amount of dark matter hitting your detector should rise and fall once a year. And DAMA's signal rises and falls once a year. The match is so strong statistically that it's almost not even a question. By the numbers, it's rock solid. There's just one problem, and it's a big one. Nobody else can see it. People were so unsettled by DAMA that they built copies, same crystals, same sodium iodide, one in Spain, one in South Korea, both designed to do nothing but check DAMA's homework. They ran for years. They stacked up their data, and they found no tide at all. Flat. When they put their results together, they could rule out DAMA's claim with real confidence, and just this year, another full dataset landed on the same answer. Whatever DAMA is seeing, it doesn't look like dark matter. So sit with that. One experiment has a beautiful, perfect, decades-long signal that does the exact dance dark matter should do. Two near-identical experiments stare at the same patch of nothing and see nothing. Somebody is wrong, and after 25 years, nobody can prove who. The signal is still there. It's still pulsing under that Italian mountain right now. And we still can't tell you what it is. Number 5. The equation that predicts galaxies. Too well. This is the one that should keep you up. Because up to now, every weird thing on this list has been dark matter behaving strangely. This one quietly asks whether dark matter is there at all. Go back to galaxies spinning too fast. The fix is dark matter. Every galaxy is wrapped in an invisible halo, and that halo's gravity holds the edges in. Fine. But here's the thing about those halos. They're supposed to be messy. Every galaxy built up its dark matter over billions of years of random mergers and collisions, a different chaotic history for each one. So the amount of dark matter, and the way it's spread out, should be all over the place. Different in every galaxy, no two the same. In 2016, 3 scientists led by a man named Stacy McGaugh lined up more than 150 galaxies and checked something simple. They asked, if you only look at the stuff you can see, just the stars, just the gas, can you predict how fast the galaxy spins? And the answer was yes, almost perfectly. One clean equation, and the visible matter alone told you the whole story every time, big galaxies and small ones falling right onto the same tidy line. That should not be possible. If there's a giant invisible halo doing most of the work, and that halo is different and messy in every galaxy, then the visible stuff should not be able to predict the answer on its own. It's like finding out you can guess a person's exact weight just from their shadow. The shadow shouldn't carry that information. Unless something is forcing the visible matter and the gravity to march in lockstep, and dark matter as we picture it has no reason to do that. There's an idea that explains this beautifully. It says stop adding invisible stuff. There is no dark matter. Gravity itself just works a little differently when it gets very weak out at the edges of galaxies, and if you change the rule of gravity by a hair, all those rotation curves snap into place, and you never need a halo at all. It's called modified gravity, and this equation is its strongest card. Now, it's not that simple, and the people who defend dark matter aren't fools. Modified gravity has its own nightmares. It struggles with those colliding clusters from item 1. It struggles with the afterglow of the Big Bang, which dark matter explains gorgeously. So most physicists still think dark matter is real, but this is the moment the floor gets a little soft. For 4 items, you've been watching us hunt an invisible substance. And here's a result sitting in plain sight, whispering that maybe we've been hunting the wrong thing the whole time, and the answer was never a particle. It was the rule. We don't know which it is. That's the honest answer. Half of the smartest people in this field are betting on a substance we've never caught, and the other half are betting we misread gravity, and the universe has not yet told either side they're wrong. Number 6, the hundreds of galaxies that should be there and aren't. Let's go back to trusting dark matter for a minute and watch it fail at something small. The big model of the universe, the one with the dark matter baked in, is genuinely incredible at the largest scales. You let it run on a supercomputer from the Big Bang forward, and it grows a universe that looks like ours. The same vast web of galaxies strung along invisible filaments, the same empty voids between them. It nails the whole cosmos. Then you zoom in on one galaxy, our galaxy, and ask it a simple question. How many little dwarf galaxies should be orbiting the Milky Way? And the model says, oh, hundreds, maybe thousands. Each big galaxy should be swarmed by a cloud of tiny ones like moths around a streetlight, because dark matter clumps at every size. We look, we count. For a long time, we found a couple of dozen, not hundreds, dozens. The streetlight is nearly dark. It got a name, the missing satellites problem. And it has a nastier cousin. The model doesn't just predict too many dwarfs, it predicts that some of them should be big and dense, so big they could impossibly fail to light up with stars. And those, the ones that should be impossible to miss, are the ones we have the hardest time finding at all. They literally called it too big to fail. And then it failed. Now, in fairness, this one's been getting better. Newer telescopes keep turning up faint little dwarfs nobody could see before, and there are good reasons a lot of those tiny galaxies might never light up. They're so small, The first stars could have boiled their gas away before they ever got going. So the gap is shrinking, but it isn't closed. And there's a strange new wrinkle where some other galaxies out there seem to have too many satellites instead of too few. The model that builds an entire universe correctly keeps miscounting our own backyard in both directions, and we still don't fully know why. Number 7. The center that's smooth when it should be sharp. Here's another place the math and the sky disagree, and it's right at the heart of things, literally. It's at the center of galaxies. When you let dark matter clump together in a simulation, it always does the same thing in the middle. It spikes. The density climbs and climbs as you head for the center, rising into a sharp point, a cusp, like the tip of a needle made of gravity. Every simulated galaxy grows one. It's one of the most reliable predictions the whole theory makes. So we go and measure real galaxies, especially the small faint ones, where a dark matter is most of the mass and easiest to weigh. We look right at the center, expecting the needle. It's not there. Instead of a sharp spike, the dark matter sits in a soft, flat, gentle pile. A core, not a cusp. Rounded off. Smooth. As if something came along and filed the point down. And nobody's totally sure what. Maybe exploding stars in the galaxy's youth shoved the dark matter around enough to puff the center out. Maybe, and this is the fun one, dark matter can actually bump into itself just a little, enough to spread out and refuse to pile into a point. That would mean the stuff isn't perfectly ghostly after all, that it has the faintest sense of touch. We don't know. But in the one place the theory is most confident, most insistent that there should be a spike, the real universe keeps handing us something smooth and shrugging. Number 8. The dwarf galaxies orbiting in a neat disk. Back to those little dwarf galaxies around the Milky Way, the ones we did manage to find. There's something deeply wrong with how they're arranged, and it might be the most quietly disturbing thing on this list. They should be a mess. Dark matter rains into a big galaxy from every direction, random angles, random orbits, so the dwarfs that ride in on it should be scattered all around the Milky Way like bees around a hive. No pattern, no order. That's what the model demands. Instead, a huge number of our dwarf galaxies lie in a single thin sheet. A plane. They're spread out in a flat disk that cuts across the Milky Way, and as far as we can tell, a lot of them are orbiting together in the same direction, like a ring turning around us. Tidy. Organized. The opposite of random. And it's not just us. Andromeda, our big neighbor, has its own plane of satellites. So does another galaxy further out called Centaurus A. When scientists ask the model how often you should see an arrangement this neat, the answer is brutal. Something like 1 in 1,000 for any single galaxy, and we found it in 3. Randomness doesn't make sheets. Something organized those dwarfs, and the standard story has no good way to do it. There is one escape hatch, and it loops us right back to the start of this video. Maybe those dwarfs weren't born the normal way at all. Maybe they're debris. Wreckage flung out in a long, thin streak by some ancient collision between galaxies, which would naturally lay them out in a plane. But here's the catch. Galaxies born from that kind of wreckage shouldn't have any dark matter, which would mean the things orbiting us in that perfect disk are the same kind of empty, dark matter-free ghosts we met in item 2. Every time you pull one thread on this, another item on the list twitches. Number 9. The X-ray glow that might be dark. Matter dying. Most of this list is about not being able to find dark matter. This one is about maybe catching it in the act of dying. In 2014, 2 separate teams were sifting through X-rays coming off enormous clusters of galaxies and off Andromeda when they both noticed the same faint extra glow. A little spike of light at one very specific energy, around 3,500 electron volts, a number that doesn't match any normal atom doing any normal thing. An unexplained line, sitting in the data that nobody had ordered. And there's a candidate that fits. Some versions of dark matter are particles that can very slowly fall apart. Decay. And when one does, it would let out a single photon of light at one exact energy. If dark matter out there is quietly decaying, the glow it gives off could look like exactly this. Which means, if that's what it is, then in 2014 we didn't just detect dark matter, we watched a little of it die and saw the flash on the way out. Or It could be nothing exotic at all. It could just be ordinary potassium or chlorine in that hot cluster gas glowing at a similar energy, fooling us. And there's a real problem with the dark matter story. If dark matter is decaying everywhere, then our own galaxy is full of it, so the glow should be all over our own sky too. People went looking for it in the empty dark around the Milky Way, where it should have been obvious. They didn't find it. That's a hard hit against the idea, so this one's still a fight. There's a new X-ray telescope up there now, sharp enough that it might finally settle whether that glow is the death cry of dark matter or just a smudge on the lens. Right now, honestly, it could be the most important light we've ever seen, or it could be nothing. We can't tell yet. Which, by now, you probably saw coming. Number 10. The dark matter hurricane blowing through you right now. Let's end somewhere close. Closer than a galaxy cluster, closer than a mountain in Italy. Let's end inside your own body. A long time ago, billions of years back, the Milky Way ate a smaller galaxy, tore it apart, and swallowed it. That happens. Big galaxies grow by devouring little ones. But the dead galaxy didn't fully disappear. Its stars and its dark matter are still out there, smeared into a long ghostly stream that wraps through the galaxy. And in 2018, using a space telescope that mapped the motions of millions of stars, astronomers realized something about one of those streams, the one they named S1. We're in it. Our whole solar system is sitting right inside the river of a galaxy that died before the Earth existed. And because that dead galaxy is moving against the grain, the dark matter in its stream isn't drifting past us gently. It's screaming past. The normal dark matter wind blows by at a couple hundred kilometers a second. This stream comes through at around 500, fast enough to cross from one side of your country to the other in a handful of seconds. A hurricane of it. The wreckage of a murdered galaxy, blowing through the solar system, through the Earth, through the chair you're in, and the hand you're holding this with. And you feel nothing. There's no wind on your skin, no cold, no sound. Billions of these particles are likely sailing through your body every second, and not one of them touches a single atom of you. You are, right now, more transparent to dark matter than glass is to light. The storm is real. It's here. It's measured. And your hand passes through it like it isn't there, because to dark matter, you're the ghost. That's the universe we live in. 5% of it is the part you can see. The rest is a stranger we can weigh and map and chart and never hold. We've watched it ride through galaxy crashes untouched. We've found galaxies it abandoned. We've buried gold mine detectors to catch it and caught nothing. We've found a signal we can't repeat, an equation that says it might not exist, and a glow that might be it dying. And tonight, 85% of everything is pouring through your body at 500 kilometers a second, and physics still cannot tell you what just passed through your hand.